This next example of homogeneous differential equation has already been identified to have repeated real roots with regards to its equivalent auxiliary equation. Hence, we are going to use a specific form of a general solution intended for solutions on situations or equations where the roots that will be solved under the auxiliary equation or equivalent auxiliary equation are real, and there are some of them which are repeated. So first, let's start by writing this equation in a form of an equation with differential operator letter D. So we can have this form here, f of d of y equal to 0. So our equation now will become this form, second degree minus 6 times the first degree plus 9 multiplied by y equal to 0. Right after this, we can now rewrite this equation into an auxiliary equation using a variable m. So from this, we can simply have here m squared minus 6m plus 9 equal to 0. As mentioned, already identified that the roots of this auxiliary equation are just the same, and then we're talking about the same because this is a quadratic equation and we expect to have two roots, but the roots are the same and both real. Okay, but of course, if this some cases where this is not identified, we still just need to continue with this step here. As mentioned, this auxiliary equation is a quadratic equation. Hence, we can simply factor this. You can also use your quadratic formula to solve for the roots. We can also factor this. This is actually a perfect square trinomial. You will have here x minus 3 times x minus 3. Sorry, not x. It's m, because that's the variable we're using here. M minus 3 times m minus 3 is equal to 0. Okay? Of course, you could try FOIL method to check whether that's the real. These are the real factors. Or you could also use here the AC method, where you have 1 times 9 is equal to 9. Factors of 9 when added, that should result to the middle term of minus 6. Of course, you could have 9 times 1, negative 1 times 9, 3 times 3, but you will use here negative 3 times negative 3, because negative 3 times negative 3 is positive 9, and when you add them up, that's minus 6. Hence, these are our factors. M minus 3 times m minus 3 is equal to 0. So as we can see here, our first root is equal to 3, but our second root is also equal to 3. We have the same roots and both of them are real numbers. Hence, as mentioned, we're going to use the specific general solution intended for homogeneous differential equations under this situation. The general solution, when our roots are repeated and they are both real, this is different from other cases where we have distinct real roots. We have videos of that already. We also have imaginary roots. We'll have it later. We also have situations where the imaginary roots are repeated. So for this instance and for this case, we will be using this general solution. Y is equal to c sub 1, any constant, e to the power of your m sub 1. Since we are using here the general solution, it's actually this form, e to the power of mx times c sub 1 plus c sub 2 x plus dot 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 until the number of times c sub n x to the power of, I believe, n minus 1 here, until the number of roots or times the roots, same roots is repeated. So you will have this form. But since we only have two roots here that are repeated, so you will have here y is equal to e to the power of mx, or let's simply substitute now our m, and our m here, our root is just a 3x times c sub 1 plus c sub 2 x until here, because you only have two roots here. This is now the solution for this given differential equation. Thank you very much for watching.